So our next speaker will be Gabriel Ruiz. Gabriel graduated from UCLA with a PhD in statistics and is now a senior machine learning engineer at Adobe. His title today will be Sample Size Planning for Conditional Counterfactual Mean Estimation with a K-armed randomized experiment. So let's welcome Gabriel.
Yeah, thank you, Tiffany, Ben, Lily, and all the organizers for this fantastic workshop. I've enjoyed the whole day today. And yeah, as Tiffany mentioned, luckily she said the mouthful for me. But yeah, I'll be talking about sample size planning for randomized experiments when you have multiple treatments, so more than two, aka K. So what are we interested in? What specific model are we interested in for understanding conditional means? We're interested in this quote-unquote feature space partition model. In other words, a way of segmenting the users in your experiment. So in this particular case, it's a lower dimensional example. We have feature 1 on the horizontal axis, feature 2 on the vertical axis, and then we have a categorical feature. Denoted by the color, you have the treatment effect. So green means treatment is effective. Red means control is better than treatment. For this arbitrary response. And then somewhere in the middle means probably no statistically significant effect. So why is this model interesting? It's a good V0 model as far as things that I've encountered in industry. It's intuitive, explainable, and then often we want to be as sure as possible with formal hypothesis testing in each bin. So such a segmentation allows us to do that. And then, for example, if you have users visiting some web page and you're interested in low latency recommendations for some treatments, if you really needed to, you can hard code the if then else rules given by a decision tree or this sort of segmentation model. And so going back a bit to why besides being interested in this type of model, why I decided to write about sample size planning. With some of the partners that we have in my current position, oftentimes the most important question we get is, okay, you want to build a recommendation model where you study treatment effects and assign users in some way like this. Do you actually need to run an experiment? If the answer is yes, the next most important question we get is, how long do you need to run it for? And we do have some kind of rules of thumb that we use in our team, but as far as what I was able to see at my current position and out in the wild, there isn't much of a good way to ballpark what a sufficient sample size you want maybe. And so I came up with a quote-unquote formula to formalize our intuition. So as far as experiment sample size planning, the more bins or treatment groups desired, the more sample needed. The higher confidence or smaller estimation error desired, the more sample needed. And so the main result we have is to be epsilon close in our mean estimation for your learned segmentation for each of the K treatments falling into any of the bins, is that with appropriate bin size constraints, the sufficient sample size is what we have here. So the sufficient sample size N depends on the number of treatments K, L, the number of bins, 1 minus alpha is in there, so that's the confidence level, and then also the noise in your data. And then in the denominator of this fraction, we have the proportion of users that go into what's called an honest set for honest prediction, which allows you to retain your nominal estimation guarantees. So this is a way to do sample splitting such that you're able to account for the fact that the segmentation that you learn is also random based on random training data. And so yeah, up in the top right-hand side, we have a plot where you have confidence level, and on the y-axis, you have in log base 10 the sample size you need for that confidence level based on different things that you plug into this formula here. So this is the archive preprint, and that's all I have. Thank you.